The last sections here in Chapter 3 are all about parallel and perpendicular lines and their slopes. So the whole unit we've been talking about parallel lines and what we get from them. Now we're going to talk about how we can show lines are parallel and perpendicular and write their equations. So quick review. Slope is defined as the change in the y-axis coordinates divided by or over the change in the x-coordinates. A lot of times people remember that as rise over run. And then the formula we use for that would be the y2 minus y1 over x2 minus x1, because that's how you would find the change in y is finding the difference, the change in x is finding the difference in the x's. We usually use the variable m to represent slope. So if I get the question, find the slope of the line passing through the points 3, 5 and negative 2, 1. Well, 3 is my x1, 5 is my y1, first x coordinate, first y coordinate. Negative 2 would be my x2, 1 would be my y2. So to use the formula, it would be y2 of 1 minus y1 of 5 over x2 of negative 2 minus x1 of 3. And I'm going to get negative 4 over negative 5, which does reduce and simplify down to a positive 4 over 5. Now I always get the question, does it matter what I use for x1 and x2? It doesn't. If I wanted to call this x2 and y2 and this x1 and y1, it doesn't matter. What matters is you leave the 2's together, x2, y2, x1, y1. That's the important part. So if I had done this backwards and I'd said y2 is 5 minus 1 over the x2 of 3 minus the x1 of negative 2, that would have given me a positive 4 over a positive 5, and I get the same thing. The only difference is you might have to deal with this double negative and simplify. But it doesn't matter which one you call x2 and which one you call x1. You could find the slope then from a given line. A lot of times you can just count. You could say this is rising 1, 2, 3, 4, 5, 6 units, and it is running to the right 1, 2, 3. Well, I went up, which is a positive 6, and I went to the right in the positive direction, so that's a positive 3. So my slope, which would be rise over run, would equal a positive 6 over a positive 3, which does reduce down to a 2 over 1, or we just say the slope is 2. What that means is I didn't have to start at these 2 points, but to go to the next point it would have been up 1, 2, right 1, up 1, 2, right 1, up 1, 2, right 1, up 1, 2, right 1. So I'm constantly getting to the next point on the line by using the slope of up 2, right 1, or a slope of 2. If I didn't want to do it that way, I could have used the formula as well. This is the point 0, 0. This is the point 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6. So this is the point 3, 6. Well, if I use the slope formula, y2 minus y1 over x2 minus x1, my first y is 6 minus my other y of 0 over my first x of 3 minus my second x of 0. Notice I'm going to get the 6 over 3, which does reduce down to 2. So you can either count and use the rise over run method, or you can just look at the points and calculate the slope using the formula. Slope-intercept form of a line is y equals mx plus b, where m, we already said, represents your slope. B is your y-intercept, or the point where it crosses the y-axis. So the y-intercept is the point where the line crosses your y-axis. If we use slope-intercept form, when I look at number 1 and where it says find the slope of the following lines, if I were to write y equals mx plus b underneath, 3 matches up to the m, 2 matches up to the b. So my slope is 3. On number 2, again, y equals mx plus b, negative 2/5 lines up with the m. My slope is negative 2/5. So people start to say things like, oh, the slope is just whatever's in front of the x. And you're right if you're in slope-intercept form. Number 3 is not in slope-intercept form. It's got the x's and the y's on the same side. So we got to change it around a little bit. I would subtract the 3x from both sides, which is going to leave me negative 2y equals a negative 3x minus 6. Notice I leave the x in front of the number 6 because I want the x then the b. So m then b. Then I'm going to divide by negative 2. Notice I'm dividing every number by negative 2, not just the 3, not just the 2. This leaves me y by itself. A negative 3 over a negative 2 is a positive 3 halves x. Negative 6 divided by negative 2 is a positive 3. So now if I were to write y equals mx plus b, 3 halves lines up with the m, so my slope is 3 halves. My y-intercept would have been 3. On number 4, here's that unique case of a horizontal line. Whenever you have y equals, you're looking at a horizontal line. Because if I was to make an xy chart, y, according to the equation, is always negative 5. So no matter what, this equation says y is negative 5. So if x is 1, y is negative 5. If x is 3, y is negative 5. If x is negative 2, so on and so forth. Any number I pick for x, y is negative 5. Well, if you were to graph that, that would be 1, negative 5, 3, negative 5, negative 2, negative 5, 4, negative 5, and we end up getting this horizontal line that is represented by y equals negative 5. Well, the slope of that, you could do the rise over run method. If I start at this point, I'm rising 0, but I am running 2. Well, my slope then would equal a rise of 0 over a run of 2. 0 divided by 2 is 0. So the slope of any horizontal line is 0. Number 5 is the exact opposite of that. If x has to equal 3, again, if I made a quick xy chart, x has to be 3. I get no choice for x. It's 3. But if x is 3, y could be anything. It could be 1, it could be 2, it could be negative 3, it could be 4. If I graph that, well, I would be at 1, 2, 3, 1, 3, 2, 3, negative 3, 3, 4, and all my points line up in this perfect vertical instead of horizontal line. So if you ever see x equals, that is your vertical line. Again, let's use the rise over run method of finding the slope here. If I start at this point, I am rising 1 unit, but I am running in the x direction 0. I'm not going to the right or to the left at all. So if I use my slope here, I would say the slope is the rise over the run, 1 over 0. You can't divide by 0, so I end up getting this idea of undefined. So if you are ever asked for the slope of a vertical line, we say it's undefined, whereas the horizontal line has the slope of 0 because you're rising 0 and running whatever to get to the next point. So remember that. Horizontal, slope 0. Vertical line, slope is undefined.